You nice and tired, puppy? Yeah. You sleepy? Good. I've had to wait until the dog's nice and tired to tell you about this maths object because it's one of her toys. It's called a Nobbly Wobbly. We bought it pretty much as soon as we got the dog, so it's a couple of years old. It's still just as good as it ever was. It hasn't broken. And so something caught my eye. It looks like it's got some sort of interesting shape to it. And then after a couple of weeks of the dog playing with it, I noticed that if you look at one of these holes where I've stuck my thumb here, there are 1, 2, 3, 4, 5 different colours going around it. That's true of every hole. Every hole has 1, 2, 3, 4, 5 colours going around it. So I think there's a dodecahedron in here. So I posted this on Google Plus a while ago, well, shortly after I discovered that. People told me some much more interesting maths about this. Would you believe that this toy that is for sale in pretty much every pet supermarket is invented by a mathematician? And there's something really, really unusual about it. You know how I said there are 5 colours around each, well, let's call them a face. The way that works is, I don't know how to show this to you, it's made up of rings. If I can trace this, whatever this colour is, all the way around the outside here, that's a single bit of rubber, and they're all interleaved with each other. But there aren't 5 of those, there are 6. So there are 6 different colours in this ball. My first reaction was that's not as good as 5, because you want 5 different colours. It's possible to 5 colour a dodecahedron, but I think not in such a way that the components are as easy to make as these simple rubber rings. And it turns out that having 6 colours is even more interesting, because the symmetry group on 6 generators, no, what do you call it, S6, permutations of 6 elements, is really interesting, and has hidden in its outer automorphism group a copy of the alternating group of 5 elements. I think that's right, I just had to look it up. Anyway, so what that means is, if I take a symmetry of this object, so something that maps one thumb hole to another hole here, that will permute the colours. So if we think of, I don't know, the colour that's not on that face as being at the end of the permutation, so that permutation that goes from that to that, that's an element of some enormous group, which is very mathematically interesting. So I've been trying to tell the dog this, and yeah, you're not having it, but it's really cool. Puppy, do you like this ball? No. So that's some unexpected maths.